Welcome everyone. This journal first presentation is about ORIS, a software tool for quantitative evaluation of non-Markovian systems. Our goal is to quickly illustrate the use cases of ORIS as a graphical application to analyze stochastic models of interest, we hope, for this community, but also as a library to write Java programs that automate the analysis and as a toolkit to support the development of such programs. The first use of ORIS is as a graphical user application to draw and analyze stochastic models. Models are defined using stochastic time Petri nets, a formalism where the state of the system is encoded by tokens inside of circular places, which enable transitions represented by vertical bars. Transitions are like actions with stochastic duration. When the tokens enable a transition, a time to fire is sampled according to some probability distribution selected by the user, maybe to fit some experimental data. If multiple transitions are enabled, there is concurrency between them, and the transition with minimum time to fire executes next, moving tokens around and possibly enabling or disabling other transitions. In this screenshot, we have a very simple model of software rejuvenation. There are two concurrent loops of sequential actions. The top loop represents the state of a software component that can be up, down after a failure, or under repair when the failure has been detected. Concurrently, in the bottom loop, there is a clock that will periodically rejuvenate the component, for example by restarting the software process. Given that the component will be unavailable during this rejuvenation, there are some parameters that we can optimize to improve system availability. For example, the frequency of rejuvenation. After drawing a model, the user can define quantitative properties, start the analysis using various engines, and visualize or export the results. The properties are defined using rewards. Rewards are expressions built from the number of tokens inside of places. In this example, the system is not available when the component is not working, token in place down, when it is under repair, token in place detected, or under rejuvenation, token in place stretch. The expected value of these reward expressions can be evaluated at different time points, as in the figure in the middle, or used as a rate to accumulate reward over time, in this case an available time of the system, as in the bottom figure. In fact, the peaks and steps here correspond to the rejuvenation times when the system becomes unavailable. ORIS is actually the result of a line of research spanning over 20 years devising methods to analyze stochastic processes produced under different constraints on the distribution of transitions. General non-exponential distributions are important to fit experimental data, but they result in non-Markovian processes, such as semi-Markov processes and Markov regenerative processes. Nonetheless, ORIS is able to analyze these processes numerically and not only by simulation. Very often, the user is not interested in the analysis of a single scenario, but in the evaluation of many system designs. To automate the construction and analysis of stochastic models, ORIS includes a Java library called Serial. This library can also be used to create extensions of the model formalism or new analysis methods, or even to implement software components that use models at runtime to adapt to the environment in which they operate. Finally, ORIS can be used as a toolkit to develop applications that construct and analyze models with its Java library. The user can define, analyze, validate models using the application, and then export them as Java code to build them with the library. Over the years, this approach has been used by several research works in the areas of railway signaling systems, real-time software, repair procedures for gas and water distribution networks, and online activity recognition for ambient assisted living. In fact, the use of ORIS as a graphical application, library, and toolkit greatly simplifies the development of services based on stochastic models. The example here is about a predictive analytics service for a bus stop, where passengers arrive as a Poisson process, but due to social distancing, only up to 10 are allowed to get on the bus, which arrives at regular intervals with random delays. The development of these services usually follows a process which starts in the ORIS application with the formulation of a stochastic model together with metrics that support the use cases of interest, such as rejection rates and wait times of passengers. And then an object-oriented domain model can be defined in Java to collect information for the different instances of the problem, with bus lines, stops, timetables, arrival rates. Now, the Java code exported from the initial ORIS model can be used to implement a model builder which visits the domain model to create different instances of the ORIS model using the library. And the analysis can be part of facade objects which can be used to evaluate metrics at runtime or offline. In our experience, ORIS can also be used to teach stochastic processes and the design of software services that use them. ORIS is freely available with an open source license. On the website we have tutorials, examples, and documentation.